Hi, hello my dear students, very good evening to all of you. Warm welcome to Turito live classes. So, we are discussing the chapter polynomials. In the previous class, we have discussed factor theorem with respect to the polynomials, and also we have discussed how to factorize the given polynomial. Okay. In today's class, we are going to discuss factorization of polynomials and methods of factorization. Okay. So, once we can recap what we have discussed in the last class, factor theorem, and we have done some problems related to that factor theorem. What is the factor theorem? If we suppose that p of x is any polynomial, if x minus a is a factor of p of x, then p of a equal to 0. Similarly, for a polynomial p of x, if x minus a equal to 0, then p of a equal to 0. So, that is factor theorem, and we have done some problems related to that. Learning objectives means what we are going to discuss in today's class. So, we will learn the following concepts in this topic: methods of factorization. When a polynomial is given, that may be quadratic polynomial or cubic polynomial, whatever the polynomial may be. So, how can we factorize that polynomial? So, methods of factorization. Next, factorization by taking out the common factor. The given polynomial may contains 2 terms or 3 terms or 5 terms or 6 terms. Whatever the number of terms may be in that polynomial, by observing all those terms in the given polynomial, we can find one term is common. So, we can take that common term as common. So, factorization by taking out the common factor. Okay. So, we are going to discuss these concepts, and we can do the problems relating to that. Next, we can do the problems related to these concepts. Now, methods of factorization. First one, factorization by taking out the common factor. In the given polynomial, if all the terms contain the same expression as a factor, then we can take that as common. So, factorization by taking out the common factor. So, if each term of the given polynomial has a common factor, then take it out as common. If all the terms of the given polynomial, whatever the number of terms may be, the given polynomial may contains 2 terms, 3 terms, 5 terms, 10 terms, whatever the number of terms may be, if all the terms of the given polynomial has one term as common, then we can take the term as common. If each term of the given polynomial has a common factor, then take it out as common. Let us take example. So, 5a square minus 20ab. So, if you take the first example, 5a square minus 28. So, first look at the numericals. What are the numericals? 5 and 20, where 20 can be written as 5 into 4. So, clearly 5 is the factor of 20. Here we have a square can be written as a into a, here we have a. So, that is why, so by writing 5 into a into a minus 5 into 4 into ab. Now, we can say 5 is the common factor, a is also common factor. So, if you take this common factor, if you take 5a as common, so since we have taken 5a as common, here the remaining part is a, minus, since we have taken 5a as common, the remaining part is 4b. So, we can express 5a square minus 20ab as 5a into a minus 4b. So, 5a square minus 20ab is the polynomial containing 2 terms. So, we have expressed that polynomial as the product of 2 polynomials. First one is 5a and second one is a minus 4b. Here 5 is common factor and a is also common factor. So, b is not a common factor because we have b in the second term, but we do not have b in the first term. So, that is why we can take 5a as common. If you take second example, 6 of 2a plus 3b whole square minus 8 into 2a plus 3b. 6 of 2a plus 3b whole square minus 8 into 2a plus 3b, where 6 can be written as 2 into 3. Here 8 can be written as 2 into 4. Can you say what is the common factor for 2 into 3 and 2 into 4? Clearly that is 2. So, we have 2 is common for both 6 and 8. So, first look at the numericals, where the numericals are 6 and 8. We can write 6 as 2 into 3 and we can write 8 as 2 into 4. So, clearly 2 is the common factor. So, we can take 2 as common. Here this is 2a plus 3b whole square. 2a plus 3b whole square means 2a plus 3b into 2a plus 3b. Here we have 2a plus 3b. So, that is why we can say 2a plus 3b is also common factor. So, that is why we can take 2 into 2a plus 3b as common. By taking 2 into 2a plus 3b as common, you will get. So, from 6 we have taken 2 as common, the remaining part is 3. From 2a plus 3b whole square, we have taken 2a plus 3b as common, the remaining part is 2a plus 3b minus. From 8 we have taken 2 as common, the remaining part is 4. So, already we have taken 2a plus 3b as common. If you want, you can write 4 into 1, that is 4 only. So, by simplifying this, 2 into 2a plus 3b into 3 2 ja 6a plus 3 3 ja 9b minus 4. So, by observing this, we have 6 of 2a plus 3b whole square minus 8 of 2a plus 3b. 6 can be written as 2 into 3, 8 can be written as 2 into 4. Now, clearly 2 is the common factor. 2a plus 3b whole square can be written as 2a plus 3b into 2a plus 3b. So, that is why we can take 2a plus 3b as common. So, by taking 2 into 2a plus 3b as common, here we have 3 into 2a plus 3b minus 4. By simplifying that, we have 2 into 2a plus 3b into 6a plus 9b minus 4. So, that is why we can express the polynomial 6 of 2a plus 3b whole square minus 8 of 2a plus 3b as 2 into 2a plus 3b into 6a plus 9b minus 4. So, we have expressed this polynomial as the product of 3 polynomials, where 2 is constant polynomial into 2a plus 3b, this is a binomial because 2 terms are there, into 6a plus 9b minus 4, that is a trinomial because we have 3 terms. So, just like this, we can take the common factor from all the terms of the given polynomial. So, first look at the given expression. So, take the numericals, next take the variables. The problem may have the variable x or y or z or a, b, c, k, l, m like that. Okay. So, now let us take some problems. So, now we are doing the problems related to the factorization of a polynomial when all the terms of the given polynomial contain a common factor. Look at this. Factorize x into x minus y whole cube plus 3x square y into x minus y. By looking at the numericals, we have only 3. So, 3 we have 3 in second term only. First term does not contain 3. That is why 3 is not a common factor. Here we have x, here we have x square. X square means x into x. X square means x into x. That is why we can say x is a common factor. In the first term we do not have y, but in the second term we have y. So, that is why y is not a common factor. Here we have x into x minus y whole cube. Here we have x minus y. So, x minus y whole cube can be written as x minus y into x minus y whole square. So, that is why we can take x minus y as common. So, by taking the given expression x into x minus y whole cube plus 3x square y into x minus y. So, we can take x as common factor. Also, we can take x minus y as common factor. So, by taking x into x minus y as common, by taking x into x minus y as common. So, since we have taken x as common, here we have 1. So, 1 into, from x minus y whole cube, we have taken x minus y as common. So, x minus y whole cube can be written as x minus y into x minus y whole square. So, since we have taken x minus y as common, the remaining part is x minus y whole square, x minus y whole square. Next, from x square we have taken x as common. X square means x into x. Since we have taken one x as common, one more x is there. So, that is 3 into x into y. So, from x minus y we have taken x minus y as common. So, 3xy into 1 only. So, from this x into x minus y into, by expanding x minus y whole square, clearly that is in the form of a minus b whole square. So, by applying the identity, a minus b whole square equal to a square minus 2ab plus b square. A square means x square minus 2xy plus y square plus 3xy. So, from this we can write x into x minus y into x square plus y square, where 3xy minus 2xy can be written as xy. 3xy minus 2xy is xy. Now, we have expressed the given polynomial x of x minus y whole cube plus 3x square y into x minus y as the product of 3 terms. First term is x, second term is x minus y, third term is x square plus y square plus xy. So, by multiplying these 3 terms again, you will get the given polynomial only, that is x of x minus y whole cube plus 3x square y into x minus y. So, hope you understood. Next, I am going to next problem. Problem number 2. Factorize 18x square y minus 24xyz. Can anyone say what is the common factor for 18 and 24? For 18 and 24, can you say what is the common factor? So, first look at the numericals. 18 can be written as 6 into 3. 24 can be written as 6 into 4. Now, what is the common factor? So, clearly that is 6. X square means x into x. Here we have x. X is a common factor. Here we have y. In second term also we have y. So, we can take y is also a common factor. But z is not a common factor because we have z in second term only. We do not have z in the first term. So, 18x square y minus 24xyz, where 18 can be written as 6 into 3. 18 can be written as 6 into 3. 24 can be written as 6 into 4. Now, this 6 is common factor. For 18 and 24, we can take 6 as a common factor. We can take x is also a common factor, y is also a common factor, but z is not a common factor. So, by taking 6, x and y as common, from 18 we have taken 6 as common. So, the remaining part is 3, 6 3 is the 18. From x square we have taken x as common. X square means x into x. Since we have taken one x as common, one more x is there, that is 3x. So, we have taken y as common. So, that is 1. So, 3x into 1, 3x only, minus 24 can be written as 6 into 4. 24 can be written as 6 into 4. So, since we have taken 6 as common, so we can take the numerical as 4. We have taken xy as common, so the remaining part is z. So, we can express the given polynomial as 6 into x into y into 3x minus 4z. So, 6xy 3x minus 4z are the factors of the polynomial 18x square y minus 24xyz. Simple problem only. So, whatever the polynomial may be, first look at the numericals. Once you can check whether there is a common factor or not. Next, you can take the numericals, you can take the variables x, y, a, b, k, l like that. So, from that we can take the numericals and variables as common and you can simplify that. Next problem. Factorize 2x into p square plus q square plus 4y into p square plus q square. What are the numericals? 2 and 4. Numericals are 2 and 4. So, clearly we can say 2 is the common factor. 2 is the common factor because 4 can be written as 2 into 2. Here we have only one x, only one y. So, x and y are not common factors. Next, if we take p square plus q square, here also we have p square plus q square. So, clearly we can say p square plus q square is also a common factor. So, we can take 2x into p square plus q square plus 4y into p square plus q square. 2x of p square plus q square plus 4y of p square plus q square. So, I am taking 2 as common and p square plus q square is also common. From 2 and 4 we can take 2 as common. From p square plus q square and p square plus q square we can take p square plus q square as common. So, by taking 2 of p square plus q square as common. So, from the first term, since we have taken 2 of p square plus q square as common, the remaining part is x. From the second term, we have taken 2 of p square plus q square as common, where 4 can be written as 2 into 2. So, 2 and we have taken p square plus q square as common, the remaining part is y. So, we have expressed the given polynomial 2x of p square plus q square plus 4y of p square plus q square as 2 into p square plus q square into x plus 2y. So, we have expressed the product of 3 polynomials 2 p square plus q square and x plus 2y, where clearly 2 is the constant polynomial, second one is p square plus q square and third one is x plus 2y. So, this polynomial contains the variables x, y, p and q. Numericals are 2 and 4 only. Okay. So, next problem. Factorize x into a minus 5 plus y into 5 minus a. By looking at the given expression, so we may say there is no common factor. But by modifying the second term or first term, you may take either first term or second term, just you can modify that, then you will get the common factor. So, first term is a minus 5, second term is 5 minus a. So, if you take 5 minus a, this can be written as minus a plus 5. I have taken minus a is the first term, 5 is the second term. Here we have a minus 5. Here also to get a minus 5, if you take minus as common a, where plus can be written as minus into minus. We know minus into minus is plus, already we have taken minus as common. So, minus 5, minus of a minus 5. So, that is why we can write 5 minus a as minus of a minus 5. Now, from the first term and second term, now we can take a minus 5 as common. So, x into a minus 5 plus y into 5 minus a. This is the given expression. So, keep the first term as it is, x into a minus 5. Modify the second term as, in place of 5 minus a, you can write minus of a minus phi. Already y is there. So, we can take minus y into a minus phi, minus a minus into minus plus phi. So, why we have modified the second term? Because to get the common factor. First term is a minus phi. To get the second term also as a minus phi, just you can take minus as common. By observing these two terms, clearly we can say a minus phi is the common term. A minus phi is the common term. So, by taking a minus phi, here we have x, here we have y. So, a minus 5 into x minus 5, a minus 5 into x minus 5. So, we can express the given polynomial x of a minus 5 plus y of 5 minus a as the product of two polynomials a minus 5 and x minus y. So, this by multiplying these two, again we will get the given polynomial only. So, hope you understood. Next problem. Factorize x of x plus y whole cube minus 3x square y into x plus y. Can anyone say what is the common factor? So, by observing the given expression, so can you say what is the common factor? So, you can send in the chat box, you can send your answer in the chat box. X of x plus y whole cube minus 3x square y into x plus y. So, very simple. Here we have x, here we have x square. X square can be written as x into x. So, x is a common factor. Here we have x plus y whole cube. X plus y whole cube means x plus y into x plus y whole square. Here we have x plus y. So, x plus y is also a common factor. Is y a common factor? No. Why? We have only y in the second term, but we do not have y in the first term. That is why we can say y is not a common factor. So, by taking x into x plus y whole cube minus 3x square y into x plus y. So, from x and x square we can take x as common. From x plus y whole cube and x plus y we can take x plus y as common. So, by taking x into x plus y, by taking x into x plus y as common. So, since we have taken x as common, here we have x plus y whole square. Since we have taken x into x plus y as common, the remaining part is minus xy. Okay. So, x of x plus y. So, since we have taken x as common, so from x plus y whole cube, since we have taken x plus y as common, we can write the first term as x plus y whole square, because x plus y whole cube means x plus y into x plus y whole square. X plus y whole cube can be written as x plus y into x plus y whole square. Since we have taken x plus y as common, the remaining part is x plus y whole square. Similarly, from x square we have taken x as common, and we also taken x plus y as common. The remaining part is x of x plus y whole square. Here 3 is also there. 3 is also there. That is not a common factor. So, since we have taken x as common, the remaining part is x, and we have taken x plus y as common. So, but 3 is not a common factor. So, we can write minus 3xy. So, x of x plus y into x plus y whole square minus 3xy. So, by expanding that, you will get x into x plus y into x square plus y square plus 2xy minus 3xy, where 2xy minus 3xy means minus xy. So, x into x plus y into x square plus y square 2xy minus xy, 3xy is minus xy. So, we can express the given polynomial as the product of three polynomials x into x plus y into x square plus y square minus xy. So, take x as common and x plus y as common. By simplifying, we got x into x plus y into x square plus y square minus xy. So, hope you understood. I am going to next problem. Problem number 6. Factorize 27a cube b cube minus 45a power 4 b square. So, by observing the numericals 27 and 45, can you say what is the common factor for 27 and 45? What is the common factor for 27 and 45? Simple. 27 can be written as 9 into 3. 45 can be written as 9 into 5. 27 can be written as 9 into 3. 45 can be written as 9 into 5. So, clearly this 9 is the common factor. Next, here we have a cube, here we have a power 4, where a power 4 can be written as a cube into a. So, a cube is also a common factor. Here we have b cube, here we have b square. So, where b cube can be written as b square into b, here we have b square. So, that is why b square is also a common factor. So, 27 a cube b cube minus 45 a power 4 into b square. So, from 27 and 45 I am taking 9 as common. So, 9 into, from a cube and a power 4 we can take a cube as common. So, we have to take the least power as common. So, by observing a cube and a power 4, a cube is the least term. So, that is why we can take a cube as common. By observing b cube and b square, b square is the least term. So, you can take b square is also common. So, by taking 9 into a cube into b square as common. So, from 27 we have taken 9 as common, the remaining part is 3. So, since we have taken a cube as common 1, 3 into 1, from b cube we have taken b square. So, what is b cube? B square into b. Since we have taken b square as common, the remaining part is b. So, 3b minus, from 45 we have taken 9 as common, the remaining part is 5. 5 into, where a power 4 means a cube into a power 4 means a cube into a. So, since we have taken a cube as common, so we have a. So, we have taken b square as common. So, we do not need to write. If you want to write 5a into 1, again you will get 5a only. So, we can express the given polynomial 27a cube b cube minus 45a power 4 b square as the product of polynomials 9 a cube b square and 3b minus 5a. Okay. Next problem. Problem number 7. Factorize 4 of a plus b minus 6 of a plus b whole square. By observing the numericals 4 and 6, can you say what is the common factor? By observing 4 and 6, what is the common factor? Very simple, 2 is the common factor. 4 can be written as 2 into 2. 6 can be written as 2 into 3. So, 2 is a common factor. Here we have a plus b, here a plus b whole square can be written as a plus b into a plus b. A plus b whole square can be written as a plus b into a plus b. So, that is why a plus b is also a common factor. 4 into a plus b minus 6 into a plus b whole square. 4 can be written as 2 into 2. 6 can be written as 2 into 3. A plus b whole square can be written as a plus b into a plus b. That is why by taking 2 into a plus b as common, by taking 2 into a plus b as common. From 4 we have taken 2 as common, the remaining part is 2. So, we have taken a plus b as common minus 6 can be written as 2 into 3. 6 can be written as 2 into 3. Since we have taken 2 as common, the remaining part is 3. A plus b whole square can be written as a plus b into a plus b. Already we have taken a plus b as common. So, one more a plus b is there, minus 3 into a plus b. So, by taking 2 of a plus b as common, we got 2 minus 3 into a plus b. So, from this 2 into a plus b into 2 minus 3a minus 3b. So, this is the product of factors of the given polynomial. Here we have three factors, 2a plus b, 2 minus 3a minus 3b. So, problems are very easy, but here by looking at the given polynomial, so you have to know which are the common factors. Okay. Finding that is very, very important. If you know what is the common factor for all the terms of the given polynomial, then you can take those terms as common and you can simplify. So, finally, we will get the product of the two or more polynomials of the given polynomial. Okay. Next problem. Factorize a cube plus a minus 3a square minus 3. Factorize a cube plus a minus 3a square minus 3. So, by observing this, so if you want from a cube plus a, you can take a as common, you will get a square plus 1. From minus 3a square minus 3, you can take minus 3 as common. So, by observing this expression, all the terms do not have the common term. So, first two terms a cube plus a have common term a. Last two terms minus 3a square minus 3 as the common term minus 3. So, that is why let us take first two terms as one group, last two terms minus 3a square minus 3 as second group. So, from this we can write a cube plus a minus 3a square minus 3, where a cube can be written as a into a square. So, we can take a as common, where from minus 3a square minus 3 we can take minus 3 as common. So, from these two terms I am taking a as common, you will get a square plus 1. From minus 3a square minus 3 you can take minus 3 as common, you will get minus 3 of a square plus 1. From the first two terms, since all the terms do not have the common term, then you can take a as common from the first two terms and minus 3 as common from the last two terms. So, from this you will get a of a square plus 1 minus 3 of a square plus 1. Again by taking a square plus 1 as common, again by taking a square plus 1 as common, you will get, so a square plus 1. So, since we have taken a square plus 1 as common, here we have a, here we have minus 3. So, we can express the given polynomial a cube plus a minus 3a square minus 3 as the product of two polynomials a square plus 1 and a minus 3. So, in the previous problems, all the terms of the given polynomial has a common factor, but here all the terms do not have the common factor. So, that is why I have considered the first two terms and last two terms. From the first two terms a cube plus a, we can take a as common. From the last two terms minus 3a square minus 3, we can take minus 3 as common. Again by taking a square plus 1 as common, we got a square plus 1 of a minus 3. Okay, next problem. Factorize 3ax minus 6ay minus 8by plus 4bx. Here also by observing all the terms do not have the common term. So, that is why just like the previous problem, let us consider the first two terms as one group and last two terms as one group. By observing 3ax minus 6ay, so 6 can be written as 3 into 2. So, 3 is a common factor. 6 can be written as 3 into 2. Also we have a. So, we can take a is also a common factor. So, 3a of x minus y, 3a of x minus y. Next, if you take the last two terms 8by plus 4bx, where 8 can be written as 4 into 2 and 4 can be written as 4 into 1. So, clearly 4 is a common factor. Similarly, b is also a common factor. So, you can take 4b as common. From the first two terms, you can take 3a as common. From the last two terms, you can take 4b as common. So, by writing the given polynomial, we have 3ax minus 6ay minus 8by plus 4bx by considering the first two terms 3ax minus 6ay. Clearly 3 is a common factor because 6 can be written as 3 into 2 and a is also a common factor. X and y are not common factors. So, that is why by taking 3a as common, here we have x, here we have minus 2y. From 6 we have taken 3 as common, the remaining part is 2. So, and you can take a is also common, a into, by taking a as common we have 1. So, 2y into 1 is 2y. Next, if we take these two terms, from these two terms if we take 4b as common plus 4b. So, I have taken 4b as common. So, by taking 4b as common, so first I am taking this term, here we have x, or you may take this term, okay, where 8 can be written as 4 into 2, 4 into 2, but here minus is there. So, minus 2 into. So, since we have taken b as common, you can take y, minus 2y plus from 4bx we have taken 4b as common. So, we can take that is x, where minus 2y plus x can be written as x minus 2y, minus 2x, sorry, minus 2y plus x can be written as x minus 2y. So, from this 3a into x minus 2y plus 4b into x minus 2y, 3a of x minus 2y plus 4b of x minus 2y. Again we can take this x minus 2y as common. So, by taking this x minus 2y as common, then we will get x minus 2y into 3a plus 4b. So, 3a plus 4b. So, we have written the given expression as the product of two polynomials x minus 2y and 3a plus 4b. So, this is first factor and this is second factor. So, we can factorize the polynomial 3ax minus 6ay minus 8by plus 4bx as x minus 2y into 3a plus 4b. So, first look at all the terms of the given polynomial, one check all the terms have a common factor or not. If all the terms do not have the common factor, then you can consider first two terms and last two terms. Again you will get one more term as common. So, from that you can write the product of the factors of the given polynomial. Hope you understood. Next, factorize abx square plus a square x plus b square x plus ab. Okay. So, here also by observing all the terms do not have the common term. So, if you take the first two terms a b x square and a square x, so a is common, x is also common. So, by taking a x as common, you will get b x plus a. Similarly, by observing these two terms b square x plus a b, clearly b is the common factor, only b is the common factor, then you will get b x plus a. So, since all the terms do not have a term in common, by taking the first two terms and last two terms. So, the given expression is a b x square plus a square x plus b square x plus a b. So, from the first two terms I am taking a as common and x as common. In the first term x square can be written as x into x. So, by taking ax as common, here we have b and x. So, bx. So, from a square we have taken a as common and x is also common. So, bx plus a plus from b square x plus ab, from b square x plus ab by taking b as common. So, b square can be written as b into b. So, that is why by taking b as common we have bx. Since from ab b is taken as common, the remaining part is a. So, by taking ax as common from the first two terms we have bx plus a. By taking b as common from the last two terms we have bx plus a. Again by observing clearly bx plus a is a common factor. Bx plus a is a common factor. That is why by taking bx plus a as common, by taking bx plus a as common, first term is ax, second term is b. So, you will get ax plus b. So, we have expressed the given polynomial abx square plus a square x plus b square x plus ab as the product of two polynomials bx plus a and ax plus b, bx plus a and ax plus b. So, when a polynomial is given, so first we have to check whether all the terms have a common factor or not. If all the terms have a common factor, then directly you can take that factor as common. Sometimes in the given polynomial, all the terms may not have a common factor. So, when we have the expression or polynomial like this, then you can consider the first two terms and last two terms. So, but every time it is not necessary to consider the first two terms and last two terms. Sometimes you may take first term, third term, second term, fourth term, or first term, fourth term, second term and third term. According to the given problem, you can write first two terms or first and last terms at one place, remaining terms at one place. Okay. By taking the first two terms as one group, second two terms as one group, then you can find which is the common factor. Take that factor as common and you can write. So, from the last two terms also you can take the common factor. So, again by taking the common factor, from that we can express the given polynomial as the product of two or more polynomials, two or more means 2, 3, 4, 5 like that. So, here we have abx square plus a square x plus b square x plus ab. So, I have taken the first two terms abx square plus a square x and last two terms b square x plus ab. So, by considering the first two terms a square. So, a is a common factor, x square can be written as x into x. So, x is also a common factor. By observing the last two terms b square x plus ab. So, by observing these two terms b square, b into b plus ab, clearly b is a common factor. So, by taking ax as common, from the first two terms we have bx plus a. By taking b as a common factor, from the last two terms we have bx plus a. So, by observing ax into bx plus a plus b into bx plus a, again by taking bx plus a as common, we got ax plus b. So, that is why we can express the given polynomial abx square plus a square x plus b square x plus ab as the product of two polynomials bx plus a and ax plus b. By observing clearly ax plus b and bx plus a both are the linear polynomials. Okay. So, just like this we can take the common factor from all the terms of the given polynomial. So, this is one method. This is one method of taking the common factor from the given terms of the polynomial. Another method is there. So, when all the terms of the given polynomial do not have, already we have done 2 to 3 problems. So, when we can regroup the terms of the given polynomial. So, from the first group or second group and third group. So, whatever the number of groups may be, again we can take the common factor from each group, again we can take the common factor. So, from that you will get the product of the polynomials. So, we can discuss that method in the next class. Okay. So, in today's class what we have discussed factorization of polynomial. So, taking out the common factor from all the terms of the given polynomial. In the next class we are going to discuss how to take the common factor by regrouping the terms of the given polynomial. So, thank you all my dear students for subscribing to Turito. Have a nice day.